For decades, we operated under a comforting illusion. We believed we fundamentally understood the grand architecture of our universe. We thought we knew how the first galaxies coalesced from pristine gas, how the earliest stars ignited, and exactly how fast the fabric of spacetime was stretching apart. But when the James Webb Space Telescope opened its golden infrared eyes and peered into the cosmic dawn, it did not find the simple, predictable void our equations had promised. Instead, it exposed a terrifying fracture in the very foundation of modern astrophysics. The telescope discovered impossible galaxies that shouldn't exist, mammoth stars seemingly powered by invisible ghosts, and a mathematical discrepancy so severe that it is currently tearing the scientific community apart. The standard model of cosmology is not just incomplete, it is profoundly broken. When astronomers looked back to the earliest epochs of the universe, they expected to find a quiet, dark place. The bottom-up theory of galaxy formation dictated that the first galaxies should be incredibly small, exceedingly faint, and composed entirely of pristine hydrogen and helium left over from the Big Bang. But then James Webb found MOM-Z14. This galaxy was observed exactly as it appeared a mere 280 million years after the Big Bang. According to every established model, MOM-Z14 had no right to exist. It was inexplicably massive. It was blindingly luminous. And most shockingly, it was heavily chemically enriched. The telescope detected highly elevated levels of nitrogen within it. To possess that kind of chemical signature, massive stars must have already formed, burned through their nuclear fuel, and violently exploded as supernovae, dispersing heavy elements into the void. MOM-Z14 had even managed to clear its surrounding region of primordial hydrogen gas. The universe was supposed to be a newborn infant, yet this galaxy was already operating with the complexity of an adult. It means that the stars in the early universe formed with terrifying efficiency, skewing heavily toward massive, short-lived monsters that completely defy our timeline of cosmic evolution. But impossible galaxies are only the surface of the anomaly. The real mystery is what hides inside them. During its deep sky surveys, James Webb detected hundreds of strange, ultra-compact objects dating back to the first billion years of the universe. Astronomers simply dubbed them little red dots. One of these objects, cataloged as 3DHST-Aegis-12014, was observed as it existed 11.8 billion years ago. For a decade, an unexplained X-ray signal from this exact location had been sitting unnoticed in the archives of the Chandra X-ray Observatory. When astronomers matched the Webb images with the X-ray data, the ruby-red blob revealed its true, terrifying nature. These are not normal galaxies. They are dense, extremely compact cocoons of gas and dust that are actively being shredded apart, and they are being torn open because a monster is eating them from the inside out. The little red dots are emerging supermassive black holes, feeding so aggressively that they are shedding their gas cocoons. But this raises a catastrophic question. How did supermassive black holes get so incomprehensibly large, so early in the universe, when there wasn't enough time for them to grow through normal mergers? To explain these overmassive black holes, astrophysicists are being forced to entertain one of the most bizarre concepts ever proposed: dark stars. In the chaotic, hyper-dense environment of the cosmic dawn, gas clouds were too hot and lacked the cooling mechanisms to easily collapse into normal fusion-powered stars. Instead, dark matter, the invisible scaffold of the universe, may have clumped together first. If dark matter particles annihilate each other when they collide, they release pure energy. This dark matter annihilation could have acted as a heat source, preventing the gas cloud from compressing into a dense core. The result would be a dark star. These theoretical behemoths wouldn't be powered by nuclear fusion. They would be powered by dark matter. They could grow to be 1,000 to 10,000 times the mass of our sun, burning with surface temperatures of 100,000 degrees. When their dark matter fuel finally ran out, these colossal titans wouldn't just explode. They would collapse directly into the supermassive black holes that James Webb is now detecting as little red dots. The cosmic dawn wasn't lit by normal stars. It may have been illuminated by monsters feeding on the dark sector. These discoveries alone are enough to rewrite textbooks. But the ultimate blow to our understanding of reality comes from something entirely different. It is a crisis concerning the very fabric of space itself. For the past century, astronomers have tried to pinpoint the exact speed at which the universe is expanding, a number known as the Hubble constant. There are two primary ways to measure it. The early route looks at the cosmic microwave background, the fading afterglow of the Big Bang, and calculates an expansion rate of 67.4 kilometers per second per megaparsec. The late route looks at the local modern universe. Astronomers build a cosmic distance ladder using pulsating stars called Cepheid variables and exploding white dwarfs known as Type 1a supernovae. The late route consistently produces a much faster expansion rate, 73 kilometers per second per megaparsec. For years, cosmologists assumed this gap was just a human error. They assumed that the old Hubble Space Telescope was miscalibrated, or that cosmic dust was messing with the measurements of the Cepheid stars. The James Webb Space Telescope, with its flawless infrared vision, was specifically tasked to look at these exact same stars, pierce through the dust, find the error, and fix the universe. But James Webb didn't find an error. It confirmed the local measurements with absolute, brutal precision. The discrepancy between the early universe and the local universe is now at a 7 sigma level of statistical significance. In science, a 7 sigma result means the probability of this being a statistical fluke is less than 1 in a trillion. It is not an error. It is a feature of reality. The local universe is aggressively tearing itself apart faster than the laws of the early universe allow. To fix this Hubble tension, we have to invent new physics. Perhaps there was a temporary surge of early dark energy just after the Big Bang. Perhaps dark energy is not a constant, but a chaotic force that evolves and strengthens over time. Or perhaps, on a cosmological scale, Einstein's theory of general relativity is simply wrong. We built the most advanced machine in human history to look back to the edge of the Big Bang and confirm our origin story. We wanted reassurance. Instead, we looked into the abyss of deep time and found impossible galaxies, stars burning invisible fuel, and an expansion rate that defies the laws of physics. The James Webb Space Telescope didn't just show us the universe. It proved to us once and for all that we have no idea what universe we are actually living in.